All right, so like I said, you guys are going to have a test. Yeah, sure. You guys are going to have a test next Wednesday. This is all a review. Somebody said yesterday, I feel like I learned this before. I was like, yeah, in the 9th grade. Okay, this is all a review. Much, much, much easier than the stuff we were just doing. You are not going to have a calculator, though. So you're going to have to know how to... you will have the opportunity to work the problems out, some of them however you want, some of them how it tells you, but you need to be able to know that if you multiply through a fraction or something, and we'll talk about that more next week, moving decimal points by just multiplying by 10 or 100, that sort of thing, to make your problem easier for whole numbers. But in a question like number 20, all right, 20 says solve the given system. Does it say you have to solve by substitution, elimination, or graphing? No, so do what you want. What is the easiest thing to do here?
Elimination.
Why elimination? Because we already have 4 y's that are the same. What's the one thing we have to change, though? One of them has to be negative. So you have to multiply one of the entire equations by a negative. It doesn't matter which one. I'm just going to do the top one. And all I'm going to do is go through here and change all of the signs. Remember, when you do anything to an equation, you do it to both sides. So if you multiply through a negative, then it has to be on both sides of the equal sign. So as we go through and we combine here, what's negative 4x and a positive 3x? Negative 1x. My 4y's cancel out. And what's negative 20 plus 15? Negative 5. So we divide both by negative 1 and x equals 5. Right? Now what do we do to find out what y is? Plug it in. Does it matter which one? No. So I'm just going to use the bottom one. 3x minus 4y equals 15. That's what we're going to plug back into. So 3 times 5 minus 4y equals 15. 15 minus 4y equals 15, right? Minus 15 from both sides. I get negative 4y equals 0. Divide by negative 4, and y equals 0. Is that an okay answer? Yes. Can you put a point on the graph that is 5, 0? You absolutely can. Remember, we talked about yesterday, if you solve something algebraically and all of your variables cancel out and you get something like x equals 9, is that a true statement? No. So then your answer here would be no solution. If you solve equations algebraically and you get something like negative 4 equals negative 4, is that true? Yes. Is that always going to be true?
No.
That negative 4 will always be negative 4? So your answer here would be infinite solutions. So you'll either get y equals something, x equals something, or you'll get an untrue statement. That would be no solution. What does it look like when you graph something and it's no solution?
Up and down.
What do you mean by up and down?
Straight line up and down.
They're both straight, but what do the lines not do?
They don't touch.
They don't touch. So you have parallel lines. Parallel lines would be no solution. An infinite solution would be you graph one of the lines and then you graph the other one and it's right on top of the first one. That means any point along that line will satisfy both equations every time.
What was it that you...
All right, moving over here. How do you have to solve this equation? Why? Because it says so, right? You can check it any other way, but it says to graph. So first thing I look for is this in y equals mx plus b? Yes. My slope here, and this first one is negative 3/4. My y-intercept is 6. So I go up to 6. 1, 2, 3, 4, 5, 6. This is a negative line, right? So it's going to be sloping downwards. So I'm going to go down 3, 1, 2, 3, and over 4. 1, 2, 3, 4. Down 3. 1, 2, 3, over 4. 1, 2, 3, 4. And we connect our lines in the straightest that we possibly can. Now I'm going to switch colors. What's my slope here? Positive 2 over 1, good. And what's my y-intercept? Negative 5. What kind of a line is this? Positive, so it's going to be going upwards. So I go down to negative 5. 1, 2, 3, 5. And I go up 2 over 1. Up 2 over 1, up 2 over 1, up 2 over 1. Can you guys see clearly where these two intersect?
Yeah.
Yes, but I want you to draw both lines. Make sure you have arrowheads on both ends. And then what is the solution? Where do these two intersect? at 1, 2, 3, 4. 1, 2, yep, 4, comma, 3. Now, algebraically, just to make sure that you graphed it properly, what could you do with the 4, comma, 3? Plug it in. Good. Very good job, guys. All right, now this one says graph. Why is this one harder to graph?
Because it's not in y equals.
Because it's not in y equals. So just take a second to do that. Put them both into y equals. I like to rewrite it. So 6x plus 3y equals negative 9. What do I do here? I have to do two things. I have to move the x where?
You have
To the other side, and then divide by the coefficient of y every single time. So I'm going to say minus 6x. Watch your signs. So you get 3y equals negative 6x minus 9. And then what do I do with the 3? Divide everything by 3. So this first line is y equals negative 2x minus 3. Negative 2x minus 3, yeah? So my slope is negative 2, and my y-intercept is negative 3. So I'm going to come over here, and I'm going to go down to negative 3. 1, 2, 3. And my slope is down 2 over 1, up 2 over 1. Why did I go in that direction?
Because it's a negative, so the direction is down.
Yep, it's a downward sloping line because it's negative. Good. So now I'm going to do the same thing. I look at the other one, and I say, okay. I have 2x plus y equals negative 3. So what do? Subtract 2x from both sides. So I have y equals negative 2x minus 3. What do you guys notice? It's the same line, right? This is my slope, and that's my y-intercept. So I go here, and I do my slope. And look, when I graph it, it goes right on top of each other. What is my answer for this question? Infinitely many. You can just put infinite many if you want to. What that means, guys, is everything. Remember, the line continues in both directions. So every single point you pick, say I pick this one and I plug it into both equations, it'll work. Say I pick this one, or this one, or this one, or this one, or one way down here, God bless you. Anything that you pick that's on that line, God bless you, will satisfy both equations because it's the same line. Does that make sense? So parallel lines that don't touch is no solution. Lines, when you graph them, that are right on top of each other, that's infinite solutions. And then when you graph them and they just intersect at one point, that's the one solution. Everybody with me? All right, moving along here, guys. This is called multilinear or nonlinear. Sometimes you'll see this called nonlinear. Linear means your exponent is to the first power, right? What do you notice about these questions? Is everything to the first power? No, everything's squared, right? So in this case, you're going to do the same thing. We're not going to graph these because they give you different shapes, but you can use substitution or elimination. And you're just going to use your basic algebra skills, and you might have to factor. But if I look at 23, what do you notice about 23? We're going to either use substitution or elimination. What looks easier? What do you notice about both of them? Why substitution? They both say y equals. What can you do to each of those things? Set them equal to each other. I can say negative 3x squared equals 6x plus 3. What do you notice about this equation, guys? It's a what? You can factor. It's a quadratic, right? We have an x squared and an x. If it's a quadratic, what do? Move everything where? So I have negative 3x squared minus 6x minus 3 equals 0. All right, this is a problem we have done from day one. If you're factoring, what do you look for first?
Two numbers.
Not yet. What do you look for first?
Oh, GCF.
GCF. What do they all have in common? Negative 3. Alex, question.
Did you have just added the 3x?
Yep, you could have just added the 3x. I just always move everything to the left. But you divide out that negative 3. Why do I divide out a negative? Because we don't like to lead with a negative. But I have x squared. Negative 6 divided by negative 3 is plus 2x. And then negative 3 divided by negative 3 is positive 1. Everybody with me? Okay. So now that negative 3 is still out front, didn't go anywhere. Geo, now what do I do?
So now you, factor.
Yep, factors of 1. What are the factors of positive 1 that multiply to give you positive 1, but add to give you 2?
1 and 1.
Perfect. X plus 1, right?
Yeah.
Good job, guys. So now what do I do to find out what x equals? You said each piece equal to? 0. God bless you. Does negative 3 ever equal 0?
No.
No. So here x equals what number? Negative 1. And x equals here what number? Okay, they both happen to be the same thing. When you have, guys, non-linear ones where it's squared, if it's squared, how many answers are you going to get? 2. If it's a third power, how many answers are you going to get? 3. So all you're doing here is the normal algebra that you would do, and then whatever x values you get, you have to plug them in to get y. So instead of getting 1 solution, you might get 2. Sometimes you get 4. But in this case, you have the same solution twice. Anybody remember what that's called?
Multiplicity.
Ooh, multiplicity. Good. So I don't have to plug my negative 1 in twice because I'm going to get the same thing. But if I know that x is negative 1, how do I figure out what y is? Plug it in. Now, you can go back to the top, guys, and plug it in either equation you want to. Which one do you want to plug it into? The first one, okay. So we're going to plug it into y equals negative 3x squared. So I have negative 3 times negative 1 squared. What do we do first? Square the negative 1. So I get negative 1 times negative 1 is 1. And 1 times negative 3 is? Negative 3. So my x value is negative 1. My y value is negative 3. In later problems that we're going to do here in a second, your x values will be different. So all you would do is you would plug in the first x value, figure out what y is. Then you plug in the second x value, figure out what y is. You just have 2 points on the graph that the equations intersect. That make sense? All right, 2 more. Look at this one. 95% of the time, guys, substitution is easier with this. Now, would you rather get this top equation to say y equals or x equals and have to worry about taking square roots and all that stuff? Or would it be easier, you think, to just take this and plug it in right there? Right? Just substitute. Just whatever variable is to the first power, substitute that equation in. So I'm going to rewrite this as x squared. Instead of y, I'm going to put 2x plus 4 equals 7. Now, when you substitute, I think it's a good idea to keep everything in parentheses first. Does it matter now if 2x plus 4 is in parentheses? No. If there was a minus sign here, though, would it matter? Yes, because what do you have to do with that minus sign? Distribute it. So just get in the habit of every time you substitute something in, just keep it in a parenthesis so you can remember if there's a negative you can distribute. So I have x squared plus 2x plus 4 equals 7. How do I solve this? Subtract 7 from both sides. Since I have a quadratic, I have 1x squared and 1x the first. So what's 4 minus 7? Negative 3. Good. Can I factor this? What times what is going to give me a negative 3, excuse me, when I multiply, but a positive 2 when I add? Plus 3 minus 1. Everybody agree? All right, so now I say x plus 3 equals 0. X minus 1 equals 0. So on this side, I get x equals negative 3. Here I get x equals 1. So how many times, if I graph these two things, how many times would they intersect? 2 times. So all you're doing here now, guys, is finding the 2 ordered pairs. You know that this x is negative 3. You got to find out what y is. You know that this x is 1. Find out what y is. And how do we find out? Plug back in. I'm going to plug it into the y equals 2x plus 4. So I'm going to take y equals 2x plus 4. That's not a 4. So 2 times negative 3 plus 4. What's 2 times negative 3? Negative 6 plus 4 is negative 2. So your first intersection point is negative 3, negative 2. What's going to happen when I plug negative 3 in for x and negative 2 in for x in my original equation? What's going to happen when I plug them in up here? It's going to be true, right? So same thing over here. I'm going to plug in. I'm going to use that same equation, y equals 2x plus 4. I get 2 times 1 plus 4. What's 2 times 1?
2.
Plus 4 is?
8. Oh.
Plus, not times. There you go. So this equation, or these two equations, if I graph them, they would cross at 2 points. They cross at -3, -2, and they would cross at 1, 6. So your nonlinear equations, guys, it's the exact same thing. You don't use elimination a lot with this, mostly substitution. But you just get more than one x value or y value, so then you find the other one. Let's do one more. And then we're done. All right, this one's a little but harder. Why? Because it's not just like super easy, right? Now, we could do a couple things. There's a couple things we could do. Do you see how this first one says y equals? Could I get the second one to say y equals? What could I do? I could move the 4x over. It would be y equals 4x plus 2. And then what could I do to those two equations? I could set them equal to each other. I can't eliminate because the variables aren't the same. Or I could take this whole thing and plug it in right there, right? Because it says y equals.
Wouldn't it be easier to set them equal to each other?
It doesn't matter. But you guys see the two different ways you could do it. I'm going to do it to set them equal to each other way. All right, we rearrange this. So they are now, we can set them equal to each other. So I'm going to say 2x squared plus 3x minus 4 equals 4x plus 2. Do you guys notice how we have a quadratic? You have an x squared and an x to the first, right? That means move everything to one side. So I'm going to subtract 4x and I'm going to subtract 2. So I get 2x squared. What's 3 minus 4? Minus 1x. And then what's negative 4 and a negative 2? Negative 6 equals 0. Everybody with me? All right, this is a factoring problem. We've all seen a bunch. A is not 1, right? So we take A times C. What are the factors of negative 12? That'll multiply to give me negative 12 and add to give me a 1. Yeah, negative 4 and positive 3, right? All right, now am I done here? Can I just go ahead and set these equal to 0? Why? Good, your A term is not 1. We have to divide by 2. I remember we started doing this at the beginning of the year, and you guys just could not get this. Now you're like, no, we keep going. Good job. All right, does anything work out nice and pretty? Yep. The first one, I have x minus 2. What about the second one? Okay. 2x plus 3 equals 0. Not a big deal, guys. Now I continue and I set each piece equal to 0. So over here I have x equals positive 2. And over here, if I move positive 3 over, it becomes negative. And then I divide by 2, so I have x equals negative 3 over 2. All right, I have a fraction. That is okay. I have two places where these two graphs are going to intersect. So I have to plug in x to one of my equations, find out what y is on the left-hand side, and I do it on the right-hand side. So let's see, which one looks easier? The bottom one, right? Y minus 4x equals 2. So I'm going to say y minus 4x equals 2. I'm plugging that into both of these x's into that. Could I have plugged it into the one that I rearranged over here? Yeah, you can. I just always go back to the original, but you can. So plug in your x. Y minus 4 times 2 equals 2. What's 4 times 2?
8.
There you go. Y minus 8 equals 2. Add 8 to both sides. What do I get over here? So my first intersection point is at 210. Okay, I'm going to come over here and do the exact same thing. Yes, I know it's a fraction, but y minus 4 times negative 3 over 2 equals 2. Okay, a negative times the negative is a positive. So I have 4 times 3 is what? 12 divided by 2 is 6.
Oh, why do I think you had
You were getting a common denominator. That's okay. Equals 2. Now what do? Subtract 6 from both sides. And over here I get y equals -4. So here the intersection point is at -3/2, -4. And that's it. Good job, guys. Very good job. So I have the review posted. It's kind of lengthy. I understand that. If you wait until Tuesday night to do it, you will not get it done. If I were you, I would look at it, do a couple graphing, a couple of this, a couple of that. There's word problems on there. We'll go over them. I promise. Probably do that Monday. And then finish up the other ones on Tuesday.
Are we going to have word problems on?
Yeah, there will be word problems on tests. Yeah. You'll be fine. That's why we're going to go over them. You'll be fine. All right. Sound good?